My name is Amjit Ramanujam, and I'm here to talk about awesome command line tools. About 5 years ago, I started a side project called pgcli, which is a command line client for Postgres databases. It had autocompletion and syntax highlighting from the terminal. And since then, it has grown into a GitHub organization called dbcli with clients for a bunch of different databases, such as MySQL, MS SQL Server, SQLite, and Redis. And there are many more, actually. If you visit dbcli.com, you'll see them. And this talk is going to walk you through some of the design decisions that made these tools successful. And I obviously took inspiration from a lot of existing well-designed command line applications. And I'm going to try and summarize what those well-designed command lines tools did different than the others that didn't do as well. But before we get started into actually jumping into the various design decisions, I want to tell you about my own journey. So I was introduced to computers in about 20 years ago. I was using MS-DOS. That was my first command line introduction. And during those days, we didn't have Stack Overflow, so I wasn't able to just simply copy and paste a command into the prompt to check out what it did. Instead, we used to thumb through a book or a manual, and whenever we saw a command that seemed interesting, like I don't know, format C: or something, we would try it out on the prompt. The issue there is that I was not a very good typer. I would make typos, and anytime I made a mistake, I had to retype the entire command from the beginning. This took this took a lot of time, and at that time, my teacher took pity at me, and he said that there is this thing called command history navigation. If you were to press the up arrow key, it will bring up the previous command that you have typed, and you could fix the typo and then press enter to make that command run. And this was such a joyous occasion for me because I obviously was awful at typing, and this saved me a bunch of time. And later, when I was introduced to Linux in my grad school, I found out that Bash also allowed me to navigate the history using the up arrow and the down arrow. But when I was pairing with a friend of mine, I noticed that he was able to complete file names and paths at a lightning speed, a speed that I've never seen before anyone type. So I asked him about it, and he introduced to me the concept called tab completion, which is when I type a prefix of a path or a file name, and I hit the tab key, Bash will autocomplete the rest of the file name for me. I didn't have to type the entire thing. Once again, this was a great day for me, even though I had now learned how to touch type, and I was typing at a furious speed of 55 words per minute. Now, the point of the moral of the story is not that command lines have awesome features. They do, and that's fantastic. The problem is that it is hard to discover them on your own, unless a friend introduces to you or a mentor introduces to you. Or you go read about it in a man page, which is a different program than the program that you're trying to use. It is very hard to stumble upon them accidentally yourself. So discoverability, how do we solve this? Well, let's take a look at some of the GUI applications and how they solve this. Any new version of an existing GUI tool is released. All the new features typically tend to get a icon in the toolbar or a entry in the menu. And being humans, we are curious, and we look at a new button, and we tend to go and poke at it. And that's a great way to discover these new features. But command line applications lack this ability. They don't have a way where you could automatically show an icon or some kind of a toolbar or anything like that, because command lines are very Spartan in their appearance. So what can we do? So let's take a look at pgcli. This is the tool that I talked about, which is a Postgres client from the command line. And how did we solve the discoverability issue in pgcli? So I briefly talked to you about tab completion. I have just connected to a Postgres database using pgcli. And when I start to type, since this is connected to a database, I'm going to run a SQL query. And as soon as I start to type SE, I notice that there is a pop-up menu, and then it gives me all the options that are available for that happen to start with the SE prefix. So now I could simply go down the menu, do select, star, from, and all of these are available. So this is what I mean, where I didn't have to press a tab key in order to trigger the completion. The auto completion was available to me as soon as I started typing them. This is a simple way in which discoverability was, one of the discoverability issues was solved in pgcli. For the next one, I want to show you fish shell. Now, if you have used bash or Z shell, you might already be aware of this little key binding, which is pressing Control R allows you to search through your history. And what you do is you press Control R and you start to type a little portion of the command that you may have typed sometime in the past, and it will search through the history, and then it will try to find the command that has the little portion of the string that you have typed, and it'll bring that up for you, so you don't have to type the entire thing. Once you have found this little key binding, you will never type a command without Control R, because there is a good chance that you have typed a command already and you're simply trying to recover it from history. So you would always type Control R, and then you would type the portion such as SSH into a host, or you're making a new virtual environment, or CDing into a particularly long path or something. You could do all of those things using Control R. Now, fish shell goes a step further. It surfaces this sort of history navigation, and it's best if I showed it to you in a quick demo. Now, this is what fish shell looks like. It is just an alternative shell for bash or Z shell. And if I start to type, let's say I do cd, and you'll see that it automatically fills in a folder name for me, because it knows that this is a command that I have typed previously, and it automatically pops it up for me. And I could press the right arrow key to fill the rest of it for me. This is particularly useful if you SSH into multiple hosts in your day-to-day job. For instance, earlier today I SSH'd into a particular machine, and I would like to SSH back into it. Instead of trying to find the host name, I could just type SSH, and it autofills the name for me. And if this is not the host that I'm interested in, I could press the up arrow key, and then it will search through the various SSH commands that I have typed in the past, and it will automatically provide them for me, and I could choose the one that I need to SSH into. This is another clever way that Fish was able to solve the issue of history navigation. Rather than binding it to a key binding, it was able to automatically surface that when it was needed, and right at the time when we would need that. So the point of discoverability is that we want to make it easy for the user to find the features, the fantastic features that command line tools have built in. How can we do that? Well, there are two things you could do. One is be more forthcoming. What I mean by that is, as soon as a feature becomes applicable to a particular scenario, surface that feature right away, rather than waiting for the user to trigger it using a tab key or some kind of a special key. So do not hide your features behind some kind of a special key, but instead make it more forthcoming and make it available as soon as it makes sense or it's appropriate for that situation. That's how we solve discoverability in some of the tools that we have built. Now, the second feature that I would like to talk about for command line applications is user focus. Now, this is not just for command line tools. This should be for any kind of a user interface at all. But the point behind user focus is that users come first. Usually, when you are trying to implement a program, you would automatically try to optimize in a way where it is easier for you to develop the code, it is easier for you to iterate on it, and so forth. But I think that should always take a backseat to how it should feel for the user. So build the interface that is most powerful for the user, most intuitive for the user, and then worry about how to implement it. How about going to implement it? I want to give you a quick example, a demonstration of what that would look like. So I'm going to take a second application called mycli, which is a MySQL command line client, which is very similar to pgcli, that talks to the MySQL database. Now, before I show you mycli, I want to show you the default MySQL client, MySQL, and I'm connecting to a particular database called world. And once I log into the database, I type SEL and I hit the tab key. In fact, I am hitting the tab key. You may not be able to see this, but there is no autocompletion, which is surprising. All right, let's try it again with uppercase. And now I hit the tab key, and there is autocompletion available. And this is what I mean by user focus, which is the programmer for MySQL could have made a simple choice where to make the autocompletion case insensitive. But it was more convenient for them to have to change it from uppercase to lowercase or lowercase to uppercase in order to show the completion. So instead, they are forcing the user to type it all in uppercase, which is a very poor choice that was made. And further that, if I do select star from and then I hit tab again, it's asking me if I would like to see 805 possibilities, which is very surprising because this is a small database that I created just for this demo, which has 3 tables at most. And so 805 is a bit surprising because after a from keyword, you always have a table name. So I press yes to see all the available options, and it's giving me every single keyword that MySQL has in its repository instead of providing me just the table names. which is again a very unfortunate way to interact with the user. Now let's contrast that to mycli. I'm connecting to mycli and I'm doing the connecting to the exact same database. And when I do that and I start to type SEL, you will notice that it immediately pops up the a auto-completion pop-up for me. And it also seems to be providing the fish style auto suggestion towards the end, but we'll get to that in just a minute. Now, if the user were to use all caps, what happens? Let's see, SEL, and it still gives them the option to autocomplete it for them. And this time the autocompletion is presented with all caps. It knows that the user prefers to use uppercase, and so it provides autocompletion in uppercase rather than providing it in the lowercase. And then if I go further and then I do select start from and then I hit the tab key, I notice that it is only giving me the 3 tables that are in this database, because after a from keyword you can only fill in a table name. And so I do that, and it goes even further. If I wanted to add a where clause, it gives me just the column names inside of that particular table. It doesn't give me everything under the sun. And then I could do any population over 500, and here are all the cities. Now this is a clear use of how the user focus comes first and the implementation second, because when I first implemented pgcli, in fact I took the same approach that MySQL was taking, which was I would show completion for every single keyword, every single table, every single column in that database, and the user has to type in order to narrow down that completion menu to find out what they're actually looking for. And when I showed it to a couple of early users, some of my friends, they told me how inconvenient it was. It gave them the illusion that it was going to do something smart, but then instead it gave them the list of everything, and they had to type in the whole name in order to figure this out. So it took me another month or so to just write the completion engine for SQL so that I could make this thing work, where it provided this context-sensitive auto-completion. Now that is a large undertaking, you might think, but it is totally worth it, because that's what made these projects actually a success. And so that's what I mean by user focus. User always comes first and the implementation later. Do not focus on the implementation. Do not try to make it easy for you to implement some feature. Make it easy for the user to make it more intuitive and make it more powerful. And the next tool that I would like to showcase for you is called bpython. This is an alternative Python interpreter that comes with autocompletion again. And let me show you what that does. So before I show bpython, I want to show you just Python REPL. And this is the standard default Python REPL. I type imp and I hit tab, and it gives me import. And I'd like to import requests module. I type req and then I hit the tab key, and it does not give me the module names, but instead it's providing me with the functions, the built-in functions that are available. It suffers from the same problem that MySQL was having, which was it is not context-sensitive completion. But let's take it even further. So I do request, and then I want to call requests get, and I hit the tab key, and it inserts a tab character into the code. Obviously, there is no use for tab key in a Python code. So this makes absolutely no sense. Let's contrast that with bpython and see how that does. Here again, I do imp, it gives me import in a little pop-up menu. I fill that in, and I do re, and it automatically gives me just the modules, and I see requests as one of the available options, and so I import requests. And then I go in and I do requests dot, and it gives me a list of all the methods that I can call on this module. I do get, and I open a bracket, and it not only gives me the arguments for that function, but it also pulls up the docstring for that particular method, which means I don't ever have to leave my Python REPL to find out how to use this particular method. I don't have to open a separate browser window to read about the documentation, or even to call help on this particular method to see the docstring. It is available right when I need it. It doesn't pop it up any time before that, but right when I'm about to give it the arguments, it tells me URL. What does URL mean, and what are the params, and what are the return type, and so forth. So that some of you might argue that this type of autocompletion or this type of documentation information can be made available in the default Python interpreter by adding a little Python RC file. Now, my argument to that is configurability is the root of all evil. This might seem like a bit of an exaggeration, but Whenever your program introduces a new configuration option, it is simply because the program is not smart enough to figure out what is the right thing to do for the user by default. It should ship with sensible defaults. It should not require configurations for the simplest things where it can figure out what is the best available option for the user is. Now, I'm not arguing that all configuration is bad. There are some configuration that is absolutely required. For instance, choosing a color scheme. This is a very subjective choice. This is based on someone's taste. Somebody likes dark color schemes. Some other folks like light color schemes, and that should absolutely be a configuration option. But having the auto completion or having the history navigation using the fish style history navigation, those things should not be configuration options, but instead they should be defaults that start up with that. Okay, so what that means is whenever you are building an application and you want to build a config file, make the config file only have the options that are subjective, taste-based options. We talked about discoverability, user focus, and configurability, and I showed demos from fish shell, bpython, pgcli, and mycli. At this time, you might be thinking, I found a bunch of new tools that I could use in my day-to-day workflow, which is great, and these seem to be, good replacements for the existing default tools, and I'll go and use them. But if I were to write my own command line client, implementing all these auto-completion or these history navigation and fish-style suggestion seems a bit of an overkill, or it's going to take more time than I could spend on my projects. So if I have to write something at work or as a side project for myself, I probably won't use these things to build it in my own. Now, you might think that these are hard features to implement, but what if I told you that you could implement all of these in mere 10 minutes? And in simply 10 lines of Python code. In fact, I'm going to do that for you right now in live. This is a checklist that I typically use. The checklist that I use is that any command line application should have a persistent history. What I mean by this is any commands that I type into a particular session, after I quit this and then I go back to the application, the history should be preserved. So I should be able to press the up arrow to see what the last command that I typed or the previous command and so forth. And I should be able to search through this history either using the Control R key, because that is now kind of ubiquitous and everybody knows about it, or using the fish style auto suggestion where it suggests things from the history itself. And in addition to that, it should also have Emacs key bindings, which is if you press Control A in your bash prompt, it takes you to the beginning of the line. Control E takes you to the end of the line. And Control B takes you one character at a time, just takes you back one character at a time. And Control F takes you forward one character at a time, and so forth. But this has become a common key binding that is available in most command line applications. And I think any command line application that you build should build this in, as the users have come to expect this. And auto-completion and syntax highlighting are what give joy to a user when they are using a particular application. So let's build all of this in about 10 minutes. Now I'm going to use a library called prompt-toolkit. It is written by Jonathan Slenders, and this is the library that is used in pgcli, mycli, and in fact all of the tools that that are under the dbcli organization. And I'm going to use that library to build a REPL. A REPL stands for read, eval, print, and loop. And what this means is you read the user input, you evaluate the input, and you print the results of that evaluation, and then you go back and ask the user for the next input. That's what a REPL is. So Python, when you type Python and you hit enter and you go into a little interpreter, that is a REPL, because it's asking for the user input, evaluates whatever you have typed, and then prints the results if there is any result, and then goes back to asking you for the next input. Now we're going to do the exact same thing here. I have a split window, and I'm going to create a brand new file called repl.py. It is absolutely blank. And on the right side, I'm going to try and run this program every time I change something on the left side. Now, if it was a regular standard Python REPL, I would use, if I'm using just default Python, then I would use input and store that into a variable, whatever the user has typed. Give it a little prompt, perhaps like that. And that will ask the user for an input and store whatever value comes back as the INP into the INP variable. Now, we're not building any kind of a regular REPL. We are building an awesome REPL. So in order to do that, we're going to import prompt toolkit and use that. Prompt toolkit import prompt. And instead of using input, I'm going to use prompt. And I mentioned that it has to continue to ask the user for multiple inputs. So I'm going to put this inside a while loop. And REPL has to evaluate it and print the results. In this case, I'm going to skip the evaluation and then print right back to the user whatever they have typed. So let us call this a echo REPL, which is whatever the user has typed in, it will print it back to the user. And with about 4 lines of code, we were able to build a simple REPL. Now it's asking us for an input. We could type hello world. I can press the up arrow, nothing happens because there is no history built into it. I can type a select command. And if I press Control A and Control E, that seems to work. Control B is working, Control F is working, and so forth. So without much effort, we have added key bindings by simply replacing the input with a prompt. If I press Control D, it quits, but it quits with a traceback. And the reason there is a traceback is because all I have to do is catch that exception and quit gracefully. We can do that at a later time, but for the sake of simplicity of the code, I'm not going to add the try except clause here. Now, the second thing we want to do is add a persistent history. Once again, we're going to use prompt-toolkit to do that. I mentioned that we want to have a persistent history, and so I would like to use the file-based history so that when I quit the application, it saves the history in a separate file. The way to do that is I add a new history keyword, and I give it a file history, and I give it a file name. Let's call it history here. Now, if I were to run this again, I do hello world, and I press the up arrow, and I have history. And I can do the select star from ABC. And now, if I press Control R, I have reverse search that's available. So I could type in world, and I get world. Or I could press select, I get select. And if I quit, and if I come back to the REPL one more time, and I still have the history available. So this is what a persistent history is supposed to do, which is it persists between program restarts. Now that's history, but using Control R is nice and all, but we would like to have fish style completion because we talked so much about it. So let's do that as well. Toolkit.autosuggest import autosuggest from history. And here I do autosuggest equals autosuggest from history. Now I quit and I relaunch it again. And now if I start to type the select statement, I see the auto-completion, auto-suggestion automatically giving me that I have already typed the select statement in the history, and so I could just press the right arrow key and get it filled in for me. And that is how we add auto-suggestion with a single line that we added to the code. Now let's add a completer so that it can pop up without having to press a tab key what possible completions are available. So again, the prompt toolkit has a completion engine that is built in, and we can do word completer. And what word completer does is if we give it a list of words and we start to type any kind of letter in the prompt, it will try to look through that list of words that we have, and then it will automatically try to match whichever word matches with whatever we have typed so far. So that's a word completer. And since I'm typing select statements, let us try and build this as an SQL completer. So we give it a list of SQL keywords. So let's give it select, show, from, where, tables. And since I made such a big deal about MySQL not being a case-insensitive completer, I'm going to set the ignore case to true so that ours can be a smarter completion engine. So I do a completer equals SQL completer. And let's try this again. Relaunching this, and I do S, and immediately a completer pops up for me. I can do show, tables, and there we go. And so this now gives me select star from ABC, where def equals ghi. So we've already built ourselves a nice little REPL that provides us with auto-completion, auto-suggestion, persistent history. One other thing that we had in the list was syntax highlighting. Let's see if we could add that. Now, syntax highlighting is going to be provided by Pygments, which is another third-party library that has built-in auto syntax highlighting for a bunch of different languages out there. So I'm going to take one of the Pygments autocompleter, and I'm going to use that with Prompt Toolkit. So Prompt Toolkit has the ability to take in multiple lexers, which can syntax highlight, and it has built-in ability to do the Pygments highlighting. So from Pygments, import actually pygments.lexers SQL, import SQL lexer. And then again, I add the next one where I say lexer equals pygments lexer of SQL lexer. And now if I go back and relaunch this, and if I do the SEL, and I'm going to use the auto suggestions to automatically fill it for me, and there it is. It is syntax highlighted for me where the coded string is clearly syntax highlighted. If I remove it, it doesn't syntax highlight for me, and so I can do it again and so forth. So that is all it took for us to build a auto-completing REPL. Now, I did say that we would be able to do this in 10 lines of code. I did take 18 lines, but let's make this. Sorry. Let's make the code slightly ugly. There we go. Voila, 10 lines of code. So if I did not bother with white spaces, then I could build a REPL in 10 lines of Python code. And let's, so this is just the code that I just typed in case I choked on the live demo. So in the checklist, we were able to implement persistent history, history search, Emacs key binding, auto-completion. In fact, we did not have any configuration at all, so that qualifies as minimal config. And we added syntax highlighting at the very end. So the resources that I covered today are a dbcli, which is the GitHub organization, and that has multiple clients inside of it. We have pgcli, mycli, lightcli for SQLite, and there's even a Redis client called iRedis. I talked about Fish Shell, which has a fantastic design philosophy document, which I take inspiration from quite a bit, that you should check out. And I mentioned bpython, which is my favorite Python REPL that I use on a daily basis. And I also talked about Prompt Toolkit, which is a library that allows us to build these rich command line applications with auto-completion and auto-suggestion and so forth.